And this worksheet, we have one question, the first question about binomial theorem. These were actually the topics that we covered last week. You remember binomial theorem, where we evaluate terms of the form x plus y to some natural number as a power, and we had the formula. So this particular example, we had it in worksheet number 5, the last worksheet. And this worksheet, we were asked to solve this using the de Morvier's theorem. So this is ultimately a complex number with a real part 1 and square root of 3 as imaginary part. And since we have other, let's say, tools to solve this, to evaluate it, we can just evaluate this number as a polar form, and then you remember we did that last time. Anyone remembers the value of this, the outcome, the result? No one remembers the result of that one? Here, it was also the first worksheet number 5. You were not attending last week. I uploaded it already. If you have a look, what was the result for this one? We evaluated it as 64. This was 64. So it's a number purely real. And here we need to evaluate it using the binomial theorem formula. What is the binomial theorem formula for that one? It says the following, that this sum, this is equal to the sum of 1 to the power 6 minus k times I . Hi, good morning. Okay, so this is, you have a copy of the worksheet? Yeah. Okay, so this is the formula where we have, something is missing here, of course. This is the, okay, let me get another one. Okay, so let's start over again for those who just came. We have the, okay, we're going to solve worksheet number 6, as you know. This worksheet, we have the first assignment that we already solved last time, worksheet number 5, using de Morvier's theorem. Here we are going to use the binomial theorem. The binomial theorem says that this is equal to the sum of the coefficients are evaluated 6 over k, 6, choose k, 1 to the power 6 minus k times square root of 3 I. This is all to the power k, where k runs from 0 to 6. Yes, do you have question?
No, sir.
I can hear you scattered. The voice is not clear. If you just write on the
No, sir, I don't have
chat.
any questions.
Yes? Come again, please. Okay, this k choose 6, or 6 choose k is defined as the factorial of 6 divided by the factorial 6 minus k times k factorial. And this is how we evaluate the coefficients. Then we have powers, and always the sum of these two powers, as you see, is going to be 6 always. Okay. So here in all, we will be having how many terms? 6 terms, right? Okay. And you remember we solved this in worksheet number 5. So this is worksheet number 5. We solve it here using De Morvier's theorem. And it was 64. Yeah, of course, here it will be also the same. Zoom out a little bit here. So here you will evaluate the coefficients, the powers, and add them up. You will see. It's a nice also exercise because you will be having things like, okay, here will run from 1 to or from 0 to 6. Just a good exercise to evaluate I to the power 5, 3, 6, whatever. So it's a good exercise, this one. Okay. Then we have 2 questions. You can think about them. These are real life questions where you need to solve simple linear equations. Now here the challenge is you need to construct the 2 in the first, or in the second, and the 3 equations in the third. So you need to construct the equations depending on the problem, how the problem is described here. Very, very simple, straightforward. Once you just construct the equations, they can be easily solved using cancellation or some maybe elimination, very simple cancellation, or even substitution. These 2 are solved also using substitution. From 0 to 6. From 0 to 6. This is the formula. You remember the formula? The formula for x plus z plus y to the power n. You remember this formula? So in this case, n is 6 and k runs from 0 to 6. Okay. And this is how we evaluate the binomials, meaning a polynomial with two terms to any power n. Okay. And I hope this is clear. What is the factorial? So we talked about this combination. So here, how to choose, how many possibilities to choose k elements out of 6 elements. Okay, so this is number 1, number 2, 3 are clear. So there here you need just to introduce some variables and then construct the equations, and the answer is straightforward. This last one here, you have two variable equations or linear systems and 1 3 variable, and you are asked to either choose substitution or elimination to solve it. So I can imagine that the first 2 not complicated, but the third can be a little bit challenging using substitution, even though it can be solved. So it's up to you. So during the lecture yesterday, or we are going also, for those who didn't attend yesterday, introduce a new system how to evaluate or solve such linear systems using the Gauss elimination method. But for now, you use substitution and simple elimination. Okay, any questions regarding the worksheet? Okay, number 2 and number 3, you have, this is what we call real life problems. Real life problems, that means it's not abstract x, y, as you see the others, x, y, z. And in this case, you have the problem is described. According to this description, you need to construct the equations. Okay, so for instance, in the first one, if you say the father's age now is x, the daughter's age is y. Okay, then what you can read from this, that the sum is 60 now. Okay, then you have two variables. You need to construct another equation given from the fact that 6 years ago the father's age was 3 times as the daughter's. Ah, think about it. Think about it. Think about it a little bit. So the second equation you need to think carefully. Okay. So first of all, you assume that the ages now of the father is x, the daughter y. Okay. Then the first equation, x plus y is equal to 60. Okay. Then the equation 6 years ago, the relationship is described there. Think about it, construct the equation and solve the two variables, and then go back to the equations and substitute to get the verification. Okay. It's just like a puzzle, you know. It's okay, guys online, clear what's meant with the assignments? Yes. Yes, but it's easy, no? Yeah. It's a good exercise because then you will learn how to evaluate things like square root of 3 to the power 6 is 3. 3 power 3, exactly. 27. And I to the power 6 is minus 1 to the power 3. Minus 1, no. So it's nice here to evaluate I to the power 3, I to the power 4, I to the power 5, I to the power 6, and also square roots. It's a bit long, but then ultimately you will be getting the same answer, hopefully. Yeah? 1, 1. It's all. Yeah. Or 0. So choose how many possibilities to choose empty set, always 1. And 6 over 6 is, or 6 choose 6 is 1 always. Huh? So square of 3i. So did you solve question number 1? So here is the solution. If you like, it's too long. I will upload it to Island. No problem. So here is I to the power 3 is equal to negative I. I hope it's clear for everyone because you have I to the power 3 is I squared. So let me just write it here. Here. Using the fact that, okay, first of all, I to to the power 3 is equal minus I, and I to the 5 equals I to the 4 is clear, 1, and I to the power 6 is negative 1. Yeah. So we use these. Yeah, so this one is negative. Then you plug it into here, you will be getting this simplification. So here I did it term by term, so using the normal theorem, can zoom out more. So sorry. What are you doubting here? You have, yeah. So here, for instance, this one 45, if you just 6 factorial over 2 times 4, so you have 15, right? You get 15. And here you get square root of 3 squared, 3. 15 times 3, you get 45. And then you get I to the power 2, which will ultimately be negative 45 here. Not clear here. So guys online, do you have any question regarding this solution? This here, 3 choose 6, 2 choose 6, and so on. It's evaluated using the formula 6 factorial over k factorial times 6 minus k factorial. I squared is minus I. Minus I is 1. Negative 1 times negative 1. I to the power 5, you have 1 times I. And I to the power 6 is minus. Okay, so then here you get 100. So you get 60 plus 60 minus square root of 3i, cancels out. Then you get 135 minus 71, and it's 64. Which is the same answer that we got in the previous worksheet. Okay, the guys online are following. I don't know. No feedback. Did you solve the first question? Any comments? Okay, so let's move to the second one. Second question says, so the second question, as I told you, the challenge is to construct the equation. So anyone solved it? What did you get here? Can you write on the comments your answers? No answers. Question number 2. Okay, here obviously you have to construct the equations given by the problem. The problem says, I hope. Okay, so solving such problems, the first thing you need to do, you need to read carefully, okay? So here, if we assume, let x, let's say x be the age of the father now, okay? And y be the age of the daughter. So someone got answer. So did you get an answer? Did you get an answer for this one? Yeah. What did you get? 42, exactly. Okay. So very simple here. The first question, the first equation, it says that the sum of the ages is 60, right? Now let's assume this is equation number 1. Now equation number 2, it says 6 years ago, the father was 3 times as old as his daughter. So that means here, what if the age of the father now is x, then 6 years ago it was x minus 6, right? And that was 3 times as the age of the daughter that time, that is y minus 6. Okay. So 6 years ago, x minus 6, the age of the father, and that was 3 times the age of the daughter 6 years ago. So here you can say it's x minus 6 equals 3y minus 18. Maybe you can simplify further. I don't know. Here you can say x equals 3y, let's say minus 12 is my second equation. Okay. So for instance, if you plug by substitution 2 in 1, if I substitute here in 1 for x equals 3y, so you will be getting 3y, for instance. Of course, you can use other methods. Minus 12 plus y equals to 60. That means 4y equals to is it correct, this one? Seventy-two over 4 is 18, right? So the age of the daughter was 18. From 1, you just plug in, you have y or x equals 60 minus y, and this is equal 60 minus 18, and this is 42. 42. So the age. So the solution here is age of father is 42, age of daughter, of course, now 18. Now you can verify, you can go to the equations, clear that the sum is 60 here. 6 years ago, the father was 6 months 36 and the daughter was 12. 12 times 3 is 36. Okay, so we verified it and it's okay. Any comments here? Guys online, are you following? We solved question number 2. So here the key is what it was here constructing these two equations, right? From the problem. So you need to give variables, assign variables, and then simplify or just so try to construct the equations and then solve using the methods we learned. Here, of course, you can also solve it using elimination or canceling, but it's simple. Two variables, two equations. You can use substitutions. Okay, question number 4 is a little bit type of a puzzle, right? So you have 3, sorry, number 3. Anyone got answer there? No, not probability. No. This is not probability. It's not. Yeah, I know. Yeah. The thing is, in probability, it's no one is drawing. Yeah, because usually in probability and statistics, you have, just choosing different colors balls. But here it's not. No, it's just about you are given some relationship between the numbers, the total of the, I don't know, the balls, the non-green, non-yellow, etc. And you need to construct actually here you have 3 variables because one is already known. Okay, you see, so the number of black is already 5. The total is 20. And I think it's straightforward. Once you can just think about how to construct the various equations, right? So try to solve it. And the guys online are still sleeping. I see no reaction from your side. Did you manage to solve it, or what does that mean? Huh? No, I am talking to the students online. No one is reacting. Huh? Maybe. Did you get result? No substitute. You can use elimination. Huh? You can use elimination. If you use elimination, you will be getting rid of one variable. Then you will need another two equations to get the one variable, then you can simplify. It's actually elimination, yeah, it's Gauss elimination, but not in form of matrices, but in equations. You work with equations at this stage. What did you get for question number 3? What? 3, 8, and 4. Yeah. It's just about, you know, the idea. I want you to think, because many students, they think it's abstract, you know, X, Y, Z. Since you are industrial engineering students, it's good to for engineering students to give you just something related to how to solve real life problems using this type of algebra. So let's see question number 3. It says here, okay, it's given we have how many? 5 black balls. So one is solved already. Then let's assume that P stands for blue, green for, or G for green, and Y for yellow. Yeah. Just to simplify things, what do we know? We know that the sum. Sorry. Girls are what? I muted them. Girls, we can hear you. So, okay, someone is writing on the chat. So, okay, so correct. Okay, so let me just show you one way of solving it. Of course, there are many other ways. So what do we know? We know that the total is 20, okay? So we have black, which is 5, plus blue, plus yellow, plus green. This is all equal to 20, okay? From this, we can say that blue plus Y plus G is equal to 15. And what else we know? We know that 17 of them are not green. That means this sum here without the green is 17, okay? So 5 plus blue plus yellow is equal to 17. From this, we got that blue plus yellow equals to 12. As you see here, you can plug this here into this one, and you will see that green is equal to 3, okay? So maybe we can number these equations. This is equation 1. This is equation 2. Okay, so substitute 2 in 1. We get 12 plus G equals to 15. And it follows that G is equal to 3. So this is the first thing. G G is equal to 3. Okay, what else do we know? We know that 12 are not yellow. 12 are not yellow. So that means here blue plus green is equal to 12. Okay? Blue plus green is equal to 12. No, not yellow. Plus 5. Okay. So not yellow means black, blue, green, and this is equal to 12. Okay, here you have also, you can substitute this here to get the blue. Blue plus, no, so to get the yellow, So here, if you just substitute from this, you get blue plus green equal to 7. Substitute in 1. In 1. Then you get blue plus green, so you get yellow equals to 8. 15 minus 7. Okay. So blue plus yellow plus green is equal 15. I have 3 and 8, 11. So it follows that you have let's say green is equal to 15 minus blue minus yellow. And this is equal to 4. Okay, so no, this is blue. No? $15. We said we have 8 blue and 8 yellow. Sorry, 8 yellow. And how many blue we evaluated here? Green. Yellow, blue, yellow, green. So the blue is yellow minus green. Okay, so 15 minus 3 minus 8, which is 4. And this is blue. Okay, so answer is 5 black, 4 blue, 3 green. Okay, so this is the final answer. Okay, so this is pretty straightforward. Now the last question, it has 3 parts. First part can be solved easily using any of the methods we learned so far, I think. Maybe this is school mathematics level. I will be surprised if anyone didn't get the right answer here. Okay, so what did you get there? So question, this one, what did you get here? So y positive or negative? First equation, you got x equals -1, right? This is -1 or +1? -1, right? So y is -5, right? Yeah. So this one you got x equals -1 and y equals -5. You can verify it here. You can say 3 times x, which is -3, -2 is -5. Okay. The second one, -1 is +1, -6 is -5. So it's okay. This one here, it has no solution because as you see here, if you consider this left-hand side, one is linear combination of another. So here you can either when you try to solve, you will be getting contradiction. Yeah, you get a contradiction, or another way to solve it. I told you, or maybe if you didn't attend the lecture yesterday, if you construct the determinant here of these coefficients, you will be having this determinant 7, 2, -21, and -6. If you evaluate this determinant, you will be having this is -42 minus 21 times 2, right? And this is going to be -42 plus 42, and it's 0. So the fact that this determinant of the coefficient is 0, it means, I'm sorry, I'm writing. Anyway, I'm sorry. It's just looks, I need to clean it up. Okay, so this determinant is 0. If the determinant is 0, then you conclude there's no solution. Okay. Okay. The determinant of the coefficient, it shouldn't be 0. This is always good attitude if you just ahead of evaluating or trying to solve the linear system to check whether this determinant is 0 or not. Because if it's 0, it means that the equations have linear dependency, and this is not allowed. Okay, no solution. Now, number 3 is a little bit challenging using these methods. Fortunately, we will learn other methods which makes it very easy to solve such linear equations of 3 variables. But here, let's try to solve it using the 2 methods. No need for that. No need. Why you need that? You just try cancellation or any method. You will end up of having. We said that in this case, contradiction means you will be having a statement that is always false. Okay, so if you want to see the answer of this one, I should have it here somewhere. And okay, here, for instance, you see, I can show you this answer here. You try to use substitution, then you end up of having 0 is equal to 72, which is not true for any value of x. Okay, it's never true because it's just what we call contradiction. Contradiction, by the way, in logic, if you studied logic, if you construct the truth table, it will be all false. Okay. Yeah, this is exactly the method to evaluate the determinant. Yeah, this is if you, these coefficients you are talking about, if they are equal, that means the determinant is equal to 0. You know how to evaluate the determinant of 2 by 2, right? Very simple. You just multiply the diagonals, cross multiplication, subtract one from the other. But where's number 3 here? I can't find it. Okay. So number 3, no, Sahil. I don't know whether I saw here someone was having some fractions in the answers. This is not the case. No. Yes, Ali, this is true. This is true. This is correct. This is correct. So I will give you some more minutes to correct your answers. I see here some other answers. Number 3 is a little bit. So if you are using substitution, it's a little bit tedious procedure, but it's possible, yeah. Then you get a question. Yeah. So what did you find the variable values at the end? Y3. You have some shift here. Just double check your calculations. Yeah? Yeah, elimination is easier for this one than using the substitution, but it's possible to use substitution. Very long and tedious procedure, but you can get answer there. So you got it? Yes, please. Last one. Yeah. 3, 2, 1. You got wrong answer at the beginning? Ah, okay. 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 See, usually very simple arithmetic can lead to problems. Okay, so if you like, just to close this is one method of solving it in both mm, substitution and in elimination. So this is second method, elimination. So obviously here you eliminate one variable, and then you plug in, you will be having another variable. So you just plug it into this, and there are, as I told you, always there are several ways of doing this, but ultimately will lead to the same answer. Uh, Okay, so from now on, we will learn, as I told you, more systematic methods to solve, in particular, 3 by 3 equations. We will learn how to use a systematical approach by Gauss elimination and Gauss-Jordan elimination methods. And then we will introduce a couple of two other very powerful methods like evaluating the inverse of a matrix and a very interesting method. It's called Kramer's method, where you need to evaluate determinants. So evaluating determinants is something very crucial for this chapter, and I urge you to just refresh your memories in practicing how to evaluate the 3 by 3 or 4 by 4 determinants. Okay, any questions? 4 by 4 sometimes with some zeros. You know, you usually evaluating the determinants, you use the so-called reduction algorithm. So usually you reduce it from n times n to n minus 1 times n minus 1. So usually with 4 by 4 determinants, it's not easy, it takes time, but if you have zeros, then you will be just reducing this in one step to one 3 by 3 determinant. Just to make sure that you understand this method of reduction of the dimension. Seems there's plus here. We have class now? Not here. Huh? No, I mean here in this room. There's class should another building. So do you need any more assistance, information? Don't only leave it to these exercises. You can also go and just check in the literature, solve problems, try to just cover the answers, solve it yourself, and see what you need to improve. This is learning mathematics, especially this Gauss elimination. You need to train, to practice. Okay, for the guys online, do you still have any problems, any questions? Regarding the worksheet. Okay, if not, sorry? No, the Gauss, did you attend the class yesterday? You attended, okay. Yeah, I will just summarize it shortly here. Okay, for the guys who are only attending the tutorial, I wish nice day, and for the others, we will meet in 15, so on 9:30 to continue with the lecture if you didn't attend yesterday. Okay, so let me just explain this. So usually, let's talk now about the 3 by 3 linear system. Okay, 3 by 3 system. So Gauss method Gauss elimination, you reduce to something that we call echelon form. And this is it's also called upper triangle. Okay? But Gauss-Jordan, you reduce it to the what we call reduced or reduced echelon form, and this you have identity. Identity means you have here something like 1 0 0 for the 3 by 3, and then you have some values, let's say A, B, C. Okay, while here you have here A, B, C, D, E, F, if you like, and here you have 0 0 0, and then you here you have G, H, I, whatever. Okay, and the difference is I think it's clear that this reduced form you have the solution straightforward. Okay, but here you need you have this form, and you need to make some calculations to get the solution. Okay, so this is the difference, and all three are using the so-called elementary row operations, which require the three operations: multiplying, dividing by non-zero, constant, adding, and subtracting two rows, and swapping the rows are the three row operations. Okay. Yeah. So the reduced echelon form, straightforward, you will say in this case, x is equal to a, b equals to b, so y equals to b, z equals to z. However, in the Gauss-Jordan form, you have to make calculations to find the values of the variables. Yes, so okay, so we will meet at 9:30 of the lecture. If you didn't attend yesterday, any questions? There's small problem here. Okay, again, can you hear me? You can see Zoom meeting starting of this. Meeting here offline. Microphone functioning. Right, so okay, media board, large break here. Microphone, media board. You can hear me, great, okay. Okay, I'm sorry, I had to move to another room and setting up this. Okay, I hope you can see the projector as well. Let me just try something here. So you can see it? Yes, okay, great. All right, so we will continue with chapter 2 actually, and in particular, we will talk about solving linear systems, and with the focus, of course, on what we call the three-dimensional or 3x3 linear system. So this is our plan for the first part of this lecture. The second part, we will just make sure that you understand the topics or the concepts of matrices, which is important for also other method of solving linear systems, like finding the inverse of the matrix and evaluating using the Kramer's rule, where you need also to know determinants. Okay, so solving. So zoom out one more. Okay, solving systems of. Is it clear, the projector, or it's a little bit too much light? Is it okay? You can read it? Okay, great. Okay, solving systems of linear equations. Last time we started with simple systems, and today, if you attended the tutorial this morning, we saw some simple methods like substitution and elimination. Okay, so we saw methods like substitution, and also elimination in general. Now, we said that these two methods, as we learned it in the previous lecture, they can work for two variable systems perfectly, but it's going to be getting a little bit more complicated when it comes to three variable and four variable. That's why I just want to focus here in this lecture on this elimination method. The elimination method, actually, it has the same basics. Yeah, it has the same basics, which is the so-called elementary row operation. Elementary row operations. And these row operations were introduced first by a famous German mathematician, his name Carl Friedrich Gauss. And in English literature, it's referred to as the Gaussian elimination method. Gaussian elimination method. Actually, when we solved this problem this earlier today, we were using these operations maybe without knowing the exact formulation of these things, like if you just multiply with a negative 2 and add it to another row and so on. So these elementary row operations for short are called ERO. The first operation is you can multiply or divide by, of course, we're talking about a row, non-zero value or constant. The second one you can add or subtract two rows. This one, of course, you can add, multiply, or divide a row. So the first one applies to one row, the second one involves two rows, and also the third one involves two rows. You can just swap two rows, meaning you just change the order of the rows. Okay, so these referred to as the elementary row operations, and these we are going to be using in a systematic way and to learn how to work with linear systems, solving linear systems using the row operations. Now, let's, before I start doing this, let's agree on the following. Now, we will be given a linear system, usually in a form of rows, where each row is referring to an equation of the system. So we will be calling the rows, numbering the rows, row 1, row 2, and so on. Just write R for this. Now, so some notation here, agreements. Now, if I'm going to perform any operation on a row, I will be just doing two things. For instance, if I'm going to add twice one row to another row, so here I'm using two rows at a time, but I'm changing only one row at a time. Okay, this is important. So working on one row is something, and working on one row is something, and changing the row is another thing. So I will be using the following notation. So we'll be using an arrow to indicate the step. And then here we will write the row that will be changed. For instance, if I want to replace row number 2 with the outcome of, let's say, adding 3 times row 1 to row number 2. Okay? So this is the meaning of replacing row 2 by the outcome of adding 3 times row 1 to row 2. Okay, I hope this is clear what is meant with this notation. Okay, so if we agree to this, we can move. Maybe before we move to this analysis that we are going to do in the next step, let me just remind you on one example that I think we just discussed this last time, which is solving a linear system in particular order. Let me just get the example. I have it somewhere here. Okay, so now we start with a linear system that is easy to solve. Okay, so here we will talk about solving a 3-variable linear system using Gauss method. Okay, now before I start with this section, I just want to